So now we're going to talk about rotary motion. We've dealt with curvilinear motion on a curve. This is complete circular motion. That's what we're going to talk about now. Motion round the circle, circular motion. That's rotary motion. In rotary motion, the same way we have equation 1, equation 2, equation 3 of motion, in linear motion, in curvilinear motion, we have also like the first one, where we have v equal to u plus at. I want to use w to represent angular velocity, because the velocity that occurs in rotary motion is angular, is in an angular form, because the distance cleared is in angles. Unlike the other motion, we clear distance in meters, in miles, in kilometers. But now the motion is round. The motion is round a circle. The motion is round. And as such, if it is round, if we start from point A, if we're in point B, here, we have covered an angle. We have covered an angle. So we measure the motion in angles, that is in degree, in radian as an angular measurement, and the revolution, because when we finish one circular full motion, we have said that it has done one revolution. So the number of times it goes around, there's a number of revolutions. So we can measure it in radian, we can measure it in degree, we can measure it in radian, because what we're covering is degrees, that is angle, that's what we're covering. Unlike the other one, we're covering distance. So we measure distance at this stage in angles, which are angular unit degree, angular unit radian. I will explain of them. And angle, full angle, which is 360 degrees, gives us a revolution. So, and the number of revolution is when it has gone to several times. We talk of number of revolutions. So we measure in radian this time around. So in angles. So we have, that's why we call the velocity is angular velocity. And the distance, or the displacement, the distance traveled, which we use this to represent distance traveled, is in degrees. It's in radian. That's in radian. So like the first and second and third equation of motion, we have here, this is W. Instead of having V is equal to U plus AT, we have W, which is the angular, which we use to represent angular velocity, is equal to U W. Yeah, that's angular initial velocity, angular final velocity plus acceleration, angular acceleration times time. That is it. Then the instead of writing S is equal to UT plus half AT squared, we have this. You are using this to represent S here. Is equal to UW, that's angular, times time, plus half angular acceleration times time squared. Then instead of writing V squared is equal to U squared plus 2AS, third equation, we have this squared is equal to U squared plus 2 this acceleration, A, that's acceleration, angular acceleration, times this. So the same way you have linear equations of motion, we also put in angular equations of motion, as shown here. So what's in angular motion, which we measure in radian, how do we do radian? We know that in a circle, if we move around a circle, which angularly we have covered 360 degrees. If we move around this circle now, we have covered 300 angularly. If we finish one complete moving around the circle, we have covered 360 degrees. And in length, what we have covered is the circumference of the circle, which is 2 pi r. So that means 360 degrees in angles is equal to 2 pi r in length. And we now take the the R, which is the radius, as the unit. So and that unit, we call it radian. We call that unit radian. So that means 360 degrees. 360 degrees is equal to 2 pi of radian. 2 pi of radians. So 2 pi radians. So 360 degrees is 2 pi radian. So while 180 degrees, which is half of 360, is pi radian. While 90 degrees is equal to pi over 2 radian. So when we are measuring we can measure in radian, we can measure in degrees, we can measure in revolution. So as we are dealing with here, we can use any of them to calculate the distance. So if we now get this in radian, if we divide by time, we get the velocity. Radian per second, radian per minute, and so on. So we can work in radian, we can work in angular distance. And when in this angular movement, that is this rotary movement, the velocity, the normal velocity, that is the velocity that is tangential, is that normal velocity at a particular time is directly proportional to the radius of the circle, which we call radius of gyration. So we have that V, which is that tangential velocity, is equal to, is direct proportional to R. If while the angular, because at a point, at a particular point, the angular velocity is constant. So at such a constant, the velocity is directly proportional to the radius of gyration, which is the radius. So this is the relationship between tangential acceleration or velocity and the angular velocity. Tangential velocity and the angular velocity. So from here, we can now get that angular velocity is equal to, the angular velocity is equal to tangential velocity divided by the radius. And this is equal to tangential velocity over the radius. Tangential velocity. And we remember that when we're dealing with curvilinear motion, when we're dealing with curvilinear motion, we have that normal acceleration is equal to v squared over r. And we have that v is equal to this. That means v is equal to wr, which means it will be equal to wr squared over r. That is normal velocity. That is normal acceleration. Is equal to w r over r, which is equal to wr. We have now seen another value of normal velocity is equal to wr, angular velocity times the radius. Angular velocity times the radius. So angular acceleration is equal to angular velocity times the radius. Angular velocity times the radius. So if we now come to tangential, acceleration, normal acceleration is equal to angular velocity times the radius. If we now come to tangential acceleration, which is equal to v over time, which means it is equal to wr over time. And w over time is, that is w is angular velocity over time will give you angular acceleration. That means it is equal to angular acceleration times r. So we have gotten now that tangential acceleration is equal to angular acceleration times radius of gyration times r. Angular acceleration times r is equal to angular acceleration times r. Angular acceleration. So tangential acceleration is equal to angular acceleration times the radius of gyration. This is what we have found out now. With this, we will solve most of the problems we have in Rotary motion. That's it. Thank you very much.